peaking. Okay, there's a rousing intro to your KIN 225 lecture for today. You can see for today's class, we're going to do a bit of a review of motor units and then talk about the muscle spindle and applications to exercise. So this is kind of a continuation from last class, where we talked about the Golgi tendon organ. This time we're applying the muscle spindle to exercise and sport situations. So, true or false? A single motor unit can have a mixture of fast twitch and slow twitch muscle fibers. This one is false. So if you look at this picture of motor units that I've been presenting, you see that a fast twitch motor neuron only has fast twitch muscle fibers, and a slow twitch motor neuron only has slow twitch muscle fibers. So you cannot have a mixture of muscle fiber types within one motor unit. One motor unit, a single motor unit, has all of the same muscle fiber types for all of its muscle fibers. Next one, when an action potential is generated in the axon of a motor neuron, only a portion of muscle fibers innervated by that axon will contract if the action potential isn't strong enough. The answer here is, again, false. So when you recruit a motor neuron, all of the muscle fibers will contract within. So if you recruit this one, these two muscle fibers would contract. If you recruited this one, the three white fibers would contract. So this is called an all or none principle. So either you're gonna get no muscle fibers contracting, or you're gonna get all of the muscle fibers contracting with recruitment of that motor neuron. So it's an all or none principle. You cannot have just a proportion of those muscle fibers activated. If the motor neuron is activated, all of the muscle fibers it innervates are going to contract. Fast twitch motor units usually have a higher number of muscle fibers compared to slow twitch motor units. This is true. So that's again illustrated in this diagram, where you can see the fast twitch motor neuron innervates a greater number of muscle fibers. So the fast twitch motor unit has a greater number of muscle fibers. And that is what defines the motor unit size. It's the number of muscle fibers that are within the motor unit. So in this case, the fast twitch motor unit has a larger size than the slow twitch motor unit. And the last question I have here is, muscle hypertrophy occurs during the first week of strength training at the same time that strength increases. This is false. So that goes back to this graph where I show the progress in training plotted as a function of time. And this time is probably in weeks or months. You can see that strength increases right away when you start a program. And that's mainly due to changes in the nervous system. So your muscle hypertrophy doesn't start to occur till about 4 weeks for some muscle groups, and then probably a little bit longer for other muscle groups. So a muscle group like the biceps hypertrophies quite quickly within 4 weeks. And then for a lower body muscle group such as the quadriceps or the hamstrings, you would probably notice significant hypertrophy after about 5 or 6 weeks of training.